In this presentation, we are going to discuss on resistor transistor logic. So in this previous presentation, we saw diode transistor logic, and after that, I have posted some videos on introduction to Karnaugh maps. So a few students suggested me to post videos on Karnaugh maps since they wanted to learn the basics of Karnaugh maps. So I have given the links for diode transistor logic in the description, and if you want you can go through the previous lecture on DTL, that is diode transistor logic. So we'll just continue with resistor transistor logic. So for a proper functioning of a transistor, you need this is the base of the transistor, and this be the collector, or this be the emitter, and this be the collector, right? This is the emitter E. The emitter E gives charges, right, which will be collected by the collector, and between the emitter and the collector there is a base. If the base is kept at the low value, for example if the base is kept at 0 or low, right, this particular transistor T will not be conducting. This transistor T will be going towards cutoff region, right? If the base of the transistor is kept high, right, in the preferred value, preferably high voltage, then the base will be able to carry the charges given by the emitter, and it will be giving to the collector, right? So if the emitter is pointing towards the base, then you can call it PNP transistor, and if it is going outside you can call it NPN transistor, right? So keeping this in mind, we'll just go through the transistor resistor transistor logic, right? So I'll just erase this part so that we can concentrate on, right? So this is the circuit diagram given to you, right? And this circuit diagram consists of two transistors, transistor T1 and this is transistor T2, right? There are three resistors. So on the top of it you can see the power supply VC, which will be plus 5 volts, right? This is resistor 1, and this is resistor 2, and this is resistor 3, right? This is the base of the transistor 1. This is B1, right? So this is the collector C1. This is the emitter E1. This emitter E1 is shorted with the emitter of the transistor T2. So you call it E2. This is the collector of transistor T2, and this is the base of the transistor, right? So since the circuit consists only of transistors and resistors, we call it resistor transistor logic, right? So here you can see the bases B1 and B2. I'll write here B2. The B1 and B2 are connected to two resistors, right? And these two resistors can be used for giving or triggering the bases. Usually we don't trigger the bases, we'll just power the bases. So we can name them A, and we can name this one as B, right? So just a minute, right? So I'll just change the color of this so we can concentrate on the truth table, right? So we have two inputs A and B, right? This is A, input A. I'll just draw a line here so that that forms a table. So this is B, right? The output is here at V0. So basically we have three elements in the truth table, right? So A and B are the two variables, and the possible combinations of zeros and ones will be 4. Beginning it will be 0 0, right? So what happens if you are giving 0 0 to A and B? So if you are applying 0 0 to A and B, right, A is 0 and B is also 0, that means both the bases of the transistors are kept at low voltage. If both of them are at low, so what happens here is that the transistors T1 and T2 are not going to conduct anything, right? That means the transistors T1 and T2 are going towards cutoff region. Since both of them are going to cutoff region, they are not conducting anything. The power is not going to flow through the collectors of transistor T1 and T2, right? So what happens here, the voltage will be driving current in this direction and in this direction, splits in this way. Since both of the transistors are not conducting, what happens here is power will be flowing outwards in this direction, right? V0 will be at high voltage, so V0 will be at high, so we can put 1 in V0. V0 is high, right? So I'll just erase this the markings, and we'll go to the next section, right? So I'll keep this B as 1, right? So A is 0 and B is 1, the next stage, right? So now A is 0 as said in the beginning, now B is 1. So A is 0, that means the base 1 here, you can see this base 1 is at low voltage. So since the base 1 is at low voltage, what happens to this transistor? The transistor is not going to conduct anything, right? The transistor will be still in cutoff region, right? So now what happens here is the base 2, right, is excited and it is now at high voltage because of the input B1. So what happens here, this power here, the voltage here will be flowing towards the collector. It will be going downwards like this, right? So majority of the voltage will be driving the current towards the collector, and more charges will be flowing towards the collector now, right? And only very low amount of charges are available at V0, right? So how do you show low voltage or low charges? Can simply put 0, right? So this is what happens in the input combination 0 1, right? The next possible combination is 1 0, right? So 1 0, so we can change the inputs here in the bottom, 1 0. So A is 1 and B is now 0. Since A is high, or A is kept at 1, or A is true, or whatever you call it, right? So the base of the transistor B1 will be at the conducting state. So the transistor now, transistor T1 now will be conducting, and it is not in the cutoff region anymore. So it will be conducting. So what happens here is from VCC, right, the current will be coming, charges will be coming, and majority of the charges will be flowing towards C1, right? Now you can see B is kept at low voltage, right? So the base of transistor T2, B2 is at low, right? So here charges will not be flowing anymore because it is in the cutoff region, right? So here the transistor T1 in this side is conducting, it is working at full effect. So majority of the current, or high voltage, or high amount of charges will be flowing towards C1, right? And only very low voltage will be available at V0. So V0 is at low voltage, right? So this is what happens when the input is 1 0, right? So what happens if the both inputs are high? A is high and B is also high. If A is also high and B is also high, that means that B is equal to 1 and A is also equal to 1. Both of them are 1. So since both of them are 1, what happens here is the bases of the transistors B1 and B2 will be at the conducting state, right? Both of them will be in the conducting state. They are not in the cutoff region anymore. So what happens here is that I'll just complete this circuit here. Please wait. I accidentally deleted this. Yes, right. So they are not in the cutoff region anymore. So what happens here? So majority of the charges will be flowing towards C2 here, and C1 and C2 here, right? As usual, here V0 will be experiencing a very low voltage, right? For the input combination 1 1, right, majority of the charges will be flowing towards both of the transistors because both of them are in the conducting state. then V0 will be at the low voltage, right? So please understand, transistors will be conducting only when the even if the emitters and the collectors are ready to exchange charges, right? The base of the transistors must be excited to a certain limit so that the exchange of charges will be happening. Even if the emitters and the collectors are ready to transfer charges, and if the base is not ready to accept it, right, the transistor will be going towards the cutoff region, right? For more information about transistors, I'll give you a link in the description that you can check about the working of NPN transistors with detailed description, how NPN transistors work and how they exchange charges and what is the governing equation of NPN transistors, right? And this is the RTL, a resistor transistor logic for NOR gates. This is NOR logic, right? This is the truth table of a NOR gate, right? The reason why we are going for the design of NOR gates and NAND gates is that they are universal gates, right? Once you design a universal gate, it is very easy to design the other gates. That is why, right? So if you have any doubts, please put it in the comment section, and thanks for watching.